5-6, we look at something called logarithms. And we've looked at solving exponential equations. For instance, 10 to what power is 1,000? X is equal to 3 here. What we've done in the past is try to get the same base on both sides. 1,000 is equal to 10 to the third power, so x has to equal 3. With the second one, we're going from a whole number to a fraction, so we need a negative exponent, not a fractional exponent, but a negative one. 4 to the x equals 16 to the negative 1. Now we try to write these two powers so that they have the same bases. 4 to the x equals 4 squared to the negative 1, so 4 to the negative 2. 4 squared is 16. Now we can say that x equals negative 2 because the bases are the same. But the third one here, 10 to the x equals 47, we don't have any way to write that so that there's the same base on both sides. And that creates an unsolvable problem for us at this point. The way we solve it is by using something called logarithms. So we're going to start out by looking at powers of 10. 100 is equal to 10 to what power? Well, x would be 2 here. And then 10 cubed is 1,000. Ten to the fourth is equal to 10,000. And now if we switch to our calculator, and we press log 10,000, there's this button over here that says log, right here. Log of 1,000 equals 3. Log of 10,000 equals 4. So what this log is doing is it's giving me the exponents from this power. So if we look down here at log 10 million, that's equal to 7. 10 to the 7th power is equal to 10 million. Log that gives us the exponents for when the base is 10 is called the common log. It's log base 10. It's finding us exponents of 10 that gives us the numbers. So with this problem, we isolate our power just like before. 10 to the x equals 1162.5. And then the way that we solve this is we're going to take the log. X is equal to the log of 1162.5. Taking the log finds us the exponent of 10 that gives us this number. And we can approximate that as I believe it's 3.05. Can double check that. .07. And we could plug that in back here and get approximately the right value. But the base that we're going to be dealing with isn't always going to be 10. Sometimes the base might be 4, sometimes it might be 9. This value of a will change, and likewise the base of the logarithm changes. But regardless of what we deal with, logs are always finding us the exponent of the base. So if we have some number raised to an exponent, it will be log base that equals the exponent. And logarithms and exponentials are inverses of each other. So now we're just going to switch back and forth between the two forms, log form to exponential form. The base of this logarithm is 125. Logs are equal to exponents, so the exponent is 2/3, and then we're equal to 25. And you could plug this into your calculator to verify that power. The second one, the base is 8. The log is equal to 1/3, so that's our exponent. This is equal to 2. Going the other direction, the base is 4, and the exponent is 3, so that's what the log equals. So log base 4 of 64 is equal to 3. The second one, the exponent is -3, so that's what the log's going to be equal to. We're base 3, so we have a subscript of 3. Log base 3 of 1/27 is equal to -3. And now we're going to solve this equation. And we're going to solve it in two ways. First, the old way. We'll write the two sides so that they have the same bases. 4 is 2 squared. So we can write 4 to the x as 2 to the 2x. 128 is 2 to the 7th. So we get 2x equals 7. Divide by 2. X is equal to 7/2. Using this new logarithm idea, we can isolate x by changing this statement into a logarithm. Log base 4 of 128. But now that raises the question, how do we figure this out? What is log base 4 of 128? The calculator only does the common log base 10. It doesn't find us exponents for when the base is 4, only for when the base is 10. But there is a way we can deal with that, and that's using this change of base formula. It says that if we have the log of some other base, we can take the common log of the big number divided by the common log of a. So in the previous problem, we had x equals log base 4 of 128. In our calculator, we can do log 128 divided by log 4. Make sure you close your parentheses. And we get the same thing, 7/2. This problem is a spin-off of yesterday's problem. We're investing our $500. This time we know the interest rate, and we want to know how long it will take to get to be $800. So 800 equals 500 times 1 plus 0.085, got to change the percent to a decimal, raised to the x. We're going to divide by 500. Eight-fifths equals 1.085 to the x power. Now that we have the power isolated, we can change into log form to find the exponent. The base we're going to be using is 1.085, of 8/5. And to deal with that in our calculator, to actually solve the problem, we're going to take the common log of 8/5 divided by the common log of 1.085. Again, make sure you close your parentheses for the top. So it's going to take about 5.8 years till we have $800.